Okay, this video is going to go over the main attributes of rational functions that you need to know going into it before you even try a rational. So let's just go ahead and get started. There's three different types of rationals. There's bottom-heavy rationals, which look like this, like you would have something like this. And when I say bottom-heavy, I'm referring to the exponents here. So like the top has an exponent of 1, the bottom has an exponent of 2. It's a higher exponent on the bottom. That means it is a bottom-heavy rational. The next type is a mid-level, and then I say the word coefficient. You'll see why later, but mid-levels are generally something like this. Look at the exponents here. You have a 1 on top and a 1 on bottom. When they match, it's a mid-level coefficient rational. And then there's top-heavy rationals, which look like this. Look at the exponents. It's a 2 on top and it's a 1 on bottom. It's heavier on the top. It means it's a top-heavy rational. So this is where I would start. I would be able to identify what type of rational you're dealing with, because each of these different types you kind of have to treat differently. So I will do a video for each of the different types, but for now, let's just focus on attributes. All right, rational functions generally have vertical asymptotes. You get the vertical asymptote by factoring the rational function fully and setting the bottom factors equal to 0 and solving. So like this particular rational function would have vertical asymptotes at x equals 3, and I'm actually going to change this to a square, and x equals -5. So that would look something like this. Here's 3. Here's -5. So that's how you find the vertical asymptotes, is by factoring the entire rational and taking the bottom factors and setting them equal to 0. Now, going deeper on vertical asymptotes, the rational function will have this vertical asymptote. It'll either have like the line going opposite ways, something like this, or it could have the line going the same way. So like this one was oppo, this one was same. The way you know what you're looking for is by looking at the exponents of these vertical asymptotes. So like this x minus 3 had a exponent of 1. When the exponent is a 1, they're going to go oppo ways. So it could either look like that, or it could even look like if this was that same vertical asymptote, instead of going up then down, it could go like down then up, something like that. Either way, they're going to go opposite directions when it's an exponent of 1. Now, when it's an exponent of 2, they're going to go the same way. So either like both down, or they could go both up. They're going to match though. So that's really important to know, because it'll help you draw these graphs. Now, holes occur when something cancels. Like imagine I had this one. All right, if this was the new problem, there would no longer be a vertical asymptote at 3. I would still have a vertical asymptote at -5. But when you have something cancel, like x minus 3 cancel, that means at an x value of 3, you're going to have a hole. And the way you find out where the hole is you plug in 3 for your x value. So like once I canceled this, it would just be a 1 on top. And if I plugged in 3, it would look like 1 over 3 plus 5, which is 1/8. That's my y value. So like this hole would occur at 3 comma 1/8, for example. So this section of line here, let me kind of clean it up a little bit for you. Would have a hole at 3 comma 1/8. So it might look something, I don't know, like this or something, but there's going to be a hole there. When they cancel, it's a hole. It's not a vertical asymptote. So that's also very important to know. Okay, moving along. All these asymptotes have either all these rationals have either horizontal asymptotes or slant asymptotes. You only have slant asymptotes on top heavy. So that means the other two, mid-level and bottom heavy, have horizontal asymptotes. Now, bottom heavy are the easiest. Bottom heavy always have y equals 0 as its horizontal asymptote. So like if it's something like this, it's going to have a horizontal asymptote of y equals 0. Now, mid-level coefficient ones, it depends on the coefficients. So like if I had something like this, my horizontal asymptote would be these coefficients right there, 2/5. That's your horizontal asymptote. You just take the coefficients, the lead coefficients, and divide them and say y equals 2/5. That is your horizontal asymptote. And then top heavy slant asymptotes, I really don't even want to get into that right now, but basically know that you'll be doing division. It'll be in my top heavy video, but for now, just know that it's done via division. So bottom heavy, always y equals 0. They always level off on the x-axis. Mid-level, it depends on the coefficients. And then top heavy, you're not going to have horizontal asymptotes. You're going to have slant asymptotes. Okay, next up, x-intercepts. You get your x-intercepts from factoring everything, and then the top you set equal to 0. So here's what I mean. First of all, look for something to cancel in case it's a hole there. Nothing cancels here. So to find the x-intercepts, you take these factors on the top and set them equal to 0 and solve. So like this one, I would have x-intercepts at 3 and at -5. And then just looking at it, I would have a vertical asymptote of 1. That's just something to always be thinking about. But you get your x-intercepts from taking the top and setting each of those factors equal to 0 and solving. Next up is y-intercept. Y-intercept is not that bad. You just set x equals to 0 and solve. You've been doing that for a while now, so that shouldn't be that difficult. Just watch your math. If you get the y-intercept, like the positive negative wrong, it'll make your entire graph wrong. Now, in behavior, these asymptotes generally, let's say I had a horizontal asymptote here, they generally level off on the horizontal asymptote. So the in behavior, look at the horizontal asymptote. That's where it should be leveling off most of the time. Now, if you had a slant asymptote, which I did not feel like talking about right now, but it would look something like this. It's just, instead of a horizontal asymptote, it's a slant asymptote. It'll level off on that slant asymptote, something like that. So you're in behavior, you're generally going to be looking at horizontal asymptote unless you have a slant, in which case you will be looking at slant asymptote. So before you go watch any of my next videos, you better know all this information. You better know the types, how to recognize the type, look at the exponents. You better know how to find the vertical asymptotes, and you know what to look for when it's a hole. Remember, a hole is when something cancels. And to find the location of the hole, like the y value, you're going to plug in the x value into the equation and solve for it. You're definitely going to need to know how to get your horizontal or slant asymptotes. I know I didn't show you slant, but how to at least get horizontal, like bottom heavy. You need to know that y equals 0 is the horizontal asymptote. Mid-level, you need to know to look at the coefficients. You need to know how to get these x-intercepts. Again, if there was something that canceled, like say I had x plus 2, x plus 2, like this, I would not have an x-intercept at 2 because these cancel. I would have a hole at 2. I mean at -2, sorry. And then lastly, last couple things, y-intercepts should not be that difficult. And in behavior, you're probably going to level out at your horizontal asymptote or your slant asymptote. And by the way, one more thing, your teacher's always been telling you, you cannot cross asymptotes. Yes, you can. You will have to sometimes. Sometimes you'll have to cross an asymptote, but you're generally still going to level out on that horizontal asymptote. Okay, I hope I didn't confuse you too much, but those are the main attributes you need to know going into any rational problem. So hope this video helped.